Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama-Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott. And we'd love for you to join us this afternoon. Give us a call if you're here in Bakersfield. The number is 636-4357. If you're in San Luis Obispo, you can also give us a call, toll free, 866-636-6284. You can email us your question, dothemath@kern.org. And of course, you can always watch the show online, dothemathonline.net. We are also available on all kinds of social media, Facebook, Instagram, YouTube, and Twitter.
All right, well, you know what? We do have phone tutors available until 5:30. Just a reminder, if you do call us from San Luis Obispo County and we put your problem on air, you will automatically receive yourself free ice cream, courtesy of Dr. Bernstein's Ice Cream Lab. We have the 5th grade call-in contest going on right now. We have an early lead.
Really?
There's a class from BMAT Elementary in the early lead for the 5th grade call-in contest. However, that is going on for the rest of today and the rest of November. So, tell your classmates if, 5th graders, like, hey, you know what? Even if you just want to check one of your problems to verify that you've been doing it correctly, that's another reason why we're here. We have a very special guest in studio. We had an excellent trip out to Casa Loma Elementary earlier today. But before we get to all of that, let's first take a look at today's Math in the News. All right, today's Math in the News, because Mary Lou is in the phone tutor studio today, and we all know that Mary Lou, as we all are, is a fan of food.
Okay.
All right,
Yeah.
so that's why, it's like, all right, Mary Lou's in studio today. Yeah, she's looking over like, hey, what's going on over there on the screen? Yeah, there's potatoes up there. Anyway, are you a fan of potatoes? Do you have a certain kind of potato you like, the way they're made?
My favorite potato is a French fry, without a doubt.
A French fry.
Yeah.
So you'll go that over baked, mashed,
Definitely. Yeah.
potato chips, anything like that.
Right.
So, you know what? It's hard not to love French fries.
That's right. Yep.
So, have you ever had sweet potato fries?
I have. I'm not a sweet potato guy, but I know people who certainly love those over any other type of fries as well. So I think it's just individual taste.
All right. Well, you know what? I found this story. The man who ate potatoes, lots of potatoes. And there was a book, The Martian.
Right.
Did you ever read that or see the movie?
Yep.
All right. So this came out back in 2014. If you haven't read the book or seen the movie, it's basically about an astronaut gets stranded on Mars and he's going to need food, has potatoes, decides he's going to be a potato farmer, wants to know if he can survive only on potatoes. Obviously, he's able to survive on potatoes. Well, there's a guy in the state of Washington. He is the executive director of the Washington State Potato Commission. And he put his money where his mouth is as to whether or not you could survive on eating only potatoes.
Uh-oh. For how long is the question?
Right. Well, okay. So, we've got the photo here of a variety of different types of potatoes. And, those little potatoes are always tasty, Yukon
They
Golds,
are,
the little
yeah.
red ones and things like that. So what he did is he put together a campaign to eat only potatoes, almost without exception, and a typical day involved no less than 20 potatoes.
Wow.
All right. So he had potato ice cream made by blending riced potatoes and ice and putting it in the freezer.
Wow.
Okay. He had a craving for pickles also. So what he did is he would soak a potato in pickle juice and then ate the potato. So therefore he's getting that flavor of the pickle. So this guy was going on and on with this thing. The goal wasn't just for publicity either. He wanted to demonstrate that a person could live on potatoes alone. Now, obviously, he drank water and things like that. But as far as the food goes, but he also says, beware. It could be dangerous. Yeah, I could imagine just eating potatoes by itself, all right? He says you need healthy kidneys to process the excess potassium delivered by 20 potatoes a day. You need other nutrients that potatoes lack, such as vitamin A for proper vision. You might have a few other things going wrong with you other than your vision if all you ate was potatoes.
Right.
But a lot of potassium, so the kidneys would need to be working well.
Yeah.
So anyway, I was like, all right, potatoes, that's a nice little story about this guy and his potato eating, and the thing with the potato ice cream and pickles. I was like, all right, we have to find something to do with potatoes.
Right.
So here we go. It's a blast from the past here.
Yeah,
We're at
Mr. Potato Head.
An opportunity to play with Mr. Potato Head right there. And just funny how you can put the different parts, different places, and things like that, and all the different combinations. So I was like, all right, that's what we're going to do.
There's
we're
certainly a math problem in there.
Combinations.
Yep.
So there are a lot of different ways you can put the eyes. So you can see here in this one, you've got 7 different sets of eyes that they could use, 4 different noses, a couple of mouths, 2 sets of ears, and you've only got the 1 set of feet. But in order to find the number of combinations for something, we put the formula up here. And not expecting the kids to be able to do this right now because this is a higher level math problem right here. But I figured let's just talk about one aspect of that formula, which is the factorial symbol, the exclamation mark. All right. And that is something that I think a lot of students will be able to understand a little bit easier, and they can do as long as they know how to multiply.
Not only that, it looks exciting. It's
right. Like, ooh, what's that symbol?
Yeah.
So 1 factorial is simply 1. 2 factorial, so you're taking the number and then the factorial are all of the numbers decreasing until you get to 1.
Right.
So we can see that 2 is 2 times 1 is 2. 3 is 3 times 2 times 1, which is equals 6. 4 factorial, well, we can take 6, multiply it by 4, you've got 24, and then so on and so forth. So the factorial is the part that we wanted to introduce students to today, in case they have not seen that little math symbol before, and that is today's Math in the News. So I was just glad I found that story on potatoes, found that kind of interesting. It was like, all right, what can we do with that? And I was like, all right, combinations on the Mr. Potato Head, and then we'll go from there.
Right.
In studio with us, we have Kaya. How are you today?
Good.
Why don't you let everybody know where you go to school and what grade you're in?
I go to Chipman Junior High, and I'm in 7th grade.
And do you have, or have you ever had, or even had the opportunity to play around with a Mr. Potato Head?
I have.
You have. You still have yours?
No.
All right. Well, I was going to say, it might be, if we had ours from when we were growing up, it would probably be
worth
worth a little bit of money right now.
Yeah.
So tell us what you remember about Mr. Potato Head.
I remember that you could change his ears around and that my brothers used to flip them upside down so that he could hear backwards.
So not only see what's going on in back of you, hear what's going on in back of you, right?
And they would switch around the parts so the eyes would be on the head or the hat would be on the nose or something.
Kind of a little Dr. Frankenstein kind of thing, right?
Yeah.
All right. Well, you know what? We're glad you're here this afternoon. Are you ready to do some work?
I am.
All right. Over to the board, young lady.
Okay.
Let's take a look at one of your homework problems right here.
Okay.
A lawn company advertises that they can spread 7,500 square feet of grass seed in 2.5 hours. So they can spread
Well, we better put some numbers
7,500
up there.
square feet of grass seed.
You want to do it?
Sure.
7,500
Square feet of grass seed.
square feet of grass seed, all right?
Okay.
And 2.5 hours is how long that will take.
And 2.5 hours. Okay, Kaya.
So the question is, find the number of square feet of grass seed that can be spread per hour.
Oh,
For 1 hour.
okay. So what do you want to do with all these numbers here?
So I'd make a proportion.
Good idea.
So you're trying to find the unit rate, which is 1 hour. Now, how do you get from 2.5 to 1 hour?
Good question. Yeah, that's exactly right. Now, are these proportions going to be equal, these two fractions?
Yes.
Okay, so we'll put an equal sign in between here. I think this is a great way to start it. So
Now-
how would you make the 2.5 go to 1 hour?
Well, at first I'd put a variable here, such as
Okay.
x, and then I'd cross multiply. So 7,500 times 1 hour equals 7,500. Now we have to figure out how to get 2.5 to 7,500.
No, hold on. You said 2.5. Where'd that come from? We have 2.5, right?
Yes. Well, you can convert this into a decimal.
Gotcha. Is it going to, why would you do that? Why would it be easier to do 2.5?
because it's easier to multiply.
Okay, that sounds good. So you want to cross that one off and just put 2.5?
Yes, please.
There you go.
So now all we have to do is divide 7,500 by 2.5.
Okay.
So let me do that down here real fast. Now what I'm going to do is I'm going to move the decimal point over 1 so that we don't deal with any decimals.
Right.
Which means I have to add another 0 and move the decimal point over 1 over here.
Gotcha, okay. So where's the decimal going to go in the answer?
Right here.
Okay, gotcha. Right above there.
Yeah. So 25 goes into 75 3 times.
Good.
And then what I would do, since I don't have to deal with all these zeros, is just put them up here. Therefore, x equals 3,000. And just to check our work, 2.5 times 3,000, or, yeah, 3,000 times 2.5. And really, all we can do is we can cross out these zeros, multiply this by 2.5. 2.5 times.
Need me to move that up a little bit for you?
Yes, please.
Get you some room there. Ooh, it jumped.
Okay. This is 15. Carry the 1. 2 times 3 is 6. Plus 7 is 7. Now this, the decimal point carried over 7.5.
Gotcha. So what happened to all those zeros there that you had? You
Now-
crossed off some zeros,
Yes,
and then you...
so now we have to add it back.
Oh, gotcha. Okay.
So now we have 7.5. So when you add zeros, you're multiplying by 10. So in this case, you'd multiply 1, 2, 3. So now we are back to 7,500.
Nice job. That was a wonderful check. Let's go back and look at this answer real quick because I really like the work you've done here. At the very top here, you said x equals 3,000, and we want to know 3,000 what? Like, what do we have there?
3,000 feet squared.
Okay, gotcha. So let's go back and make sure we understand the question to make sure you've answered it correctly. What was the final question there, Mike?
So let's take a look at it. It says, find the number of square feet of grass seed that can be spread per hour.
Gotcha.
Per
So you
hour.
came up with a square foot number.
Yes.
So 3,000 square foot of grass seed
Can be spread each hour.
each hour. That's right. Well done. Gosh, that was really solid. Well done.
There you go. Nicely done, Kaya. You know what, Scott? Between the young lady yesterday, Morgan, and Kaya today, we can just take off the microphones.
Yeah, pretty soon I think I'm going to be taking a chair in the back.
We've been substituted now with these two young ladies. 636-4357 is the phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. We do have the 5th grade call-in contest going on throughout the month of November. And earlier today, Do the Math had an opportunity to visit Casa Loma Elementary School and check out the Mobile Oil Learning Unit. Let's see what Devin found out.
Hey, thanks a lot, Mike. We're here today at Casa Loma Elementary, a very active, lively, energetic campus. And we're here with the MOLU. They've set up shop, joined now by Traco Matthews as an Air Ambassador. And you guys really set up shop and really taking a good foothold of the site here. Tell us what's going on.
Absolutely. So I'm here with Air Energy, and we are sponsors of the MOLU here at Casa Loma because this is something that we love to do, invest in our communities, and this is exactly in our wheelhouse. The MOLU, or the Mobile Oilfield Learning Unit, is a 6-station exhibit that teaches kids about the oil industry, step by step, the technical side, career opportunities, and we love this because a lot of people don't know exactly what ERA does.
A lot of times that information is out there, but bringing it to the campus is really important so that kids can make that immediate connection with all of the methods and modes of processing and distributing oil.
Absolutely. So one of the stations, Station 5, I love it. It actually takes them through from start to finish. So it talks about how they get oil out of the ground, the refining process, and then how it gets to a gas station. Simple, easy for a kid to understand. Everyone drives a car, their parents drive a car, so it makes it accessible and simple for the kids.
You find that happens a lot with some of the kids where they may make a connection of something that they see quite a bit and all of a sudden becomes very real as part of that process.
Oh my God, that's the part I love most. So if you walk around, they have these little books, and they're answering questions and they're writing in their journals, and all of a sudden it'll hit them. They'll have this epiphany. and you see that illumination go off in their minds, and they're like, ah, I understand it now, it makes sense. And an example with permeability and porosity, they're looking at how water drops through different sized stones or marbles, and all of a sudden it goes off and they're like, oh, this makes sense. That's the best part of this whole experience, is them getting to understand and have those moments of illumination.
Now, Casa Loma is just one of many sites that you'll be visiting with the MOLU. Tell us a little bit about the reach of the activities here.
So absolutely. So the MOLU comes usually every couple of years in conjunction with the Current Energy Festival. And ERA, Chevron, CRC, CEI, and different trade associations, we work together to bring it out from Houston, usually to make sure that it's going to get to the Current Energy Festival every 2 years, but also we want to make sure that students at different schools have an opportunity to see it up close and personal firsthand.
So about how many schools in California do you anticipate visiting?
Wow, so California total, it'll probably go to 15 different schools up and down the state.
Tremendous. I mean, one of many, and we'll explore some of these stations a little bit later on. I also want to have the opportunity to speak to the principal here at Casa Loma Elementary, Lamel Kwan. Ms. Kwan, thank you for joining us this morning. So, you've seen the kids really interacting with a lot of these visiting stations here. It's not the first time we've had something like this here at Casa Loma.
Right, so we're really grateful to have Era Energy partner with us. So in early October, they actually came out with the geologists from Era Energy and provided hands-on activities directly relating to geology and earth sciences. So it's even more exciting to give our students this opportunity with us, 6 stations, connecting what they're learning in the classroom with hands-on activities. What's really exciting for me as a principal is giving them that opportunity to see what future careers that they can go into later on in their life.
Beyond that, too, the interaction with field engineers is really powerful. That opportunity to say, like, don't worry about what you want to be when you grow up. This is something that you can make sense of and process now, and this is kind of a pathway on how you can get there.
Exactly. So that's the neat part about it, is they can relate directly to the geologists and the engineers who are here, and to be able to ask them questions. If they're not sure about what's going on in this exhibit, they can answer the questions and provide that direct support for the students.
I mean, you also have the opportunity to really get out of the classroom and bring that beyond simply just the stations themselves. It really expands the learning from outside the 4 walls.
Exactly. So again, it's bringing that real life science and technology into real life, and to be able to have them interact with the hands-on activities, connecting it with what they're learning in the science standards, and being able to see it visually is even more exciting for the students.
So Treko had mentioned we got about 6 stations here at the MOLU at our site here at Casa Loma Elementary today. A little bit later on in the show, we're going to start exploring some of those and really start to get into the process brought in by ERA and the ambassadors here with the Mobile Oil Learning Unit. So we're going to come back to you in a little bit, but for now, Mike, take it right back to the studio.
All right, thanks for that. 636-4357 is the phone number. Phone tutors are available until 5:30. Speaking of the phones, we're going to go to the phones right now. And Morgan, how are you today?
I'm good.
And you're a 6th grade student at Lum, correct?
Yes.
And I'm going to take it that you are the same Morgan that was on the program yesterday, correct?
Maybe.
Oh, maybe. Ooh, all right. Well, maybe we'll do your problem now. All right. All right. Let's hear the math problem you're working on.
Okay. So it's 2 open parentheses n plus 4 end parentheses equals 3 open parentheses n minus 2 end parentheses.
That's a good problem, Morgan. I like it. What do you want to do first here?
So we want to distribute the 2 in the parentheses.
Okay, so we're going to use the distributed property, and we'll go 2 times n and 2 times 4. Okay, so what's the result here? What's 2 times n?
2n.
Okay. And 2 times positive 4?
Positive 8.
There you go. Good job. Should we keep those parentheses in there, or do you want to drop them?
Drop them.
Okay, gotcha. So the distributed property makes those go away. I'm going to go ahead and cut this equation right in half here. How about the other side?
We want to distribute the 3 into the parentheses.
That sounds good. 3 times n is 3n. What about 3 times negative 2?
Negative 6.
Good job. All right. Now you have a big decision to make here, Morgan. We would certainly like to get all of those letters all together, right?
Mm-hmm.
But we have some n's on the left and we have some n's on the right. Which side do you want to put the n's on?
The left side.
You want to put them on the left. That's probably a good choice. So that means the numbers probably have to go to the right. Would you agree?
Yes.
Okay, so how are you going to move that 8 over to the right-hand side?
Subtract it by negative 8.
Okay, so we'll go minus 8 here. And on the other side as well?
Subtract it by -8.
Yeah, same thing, right? So whatever you do to one side, got to do it to the other. Okay, so we've moved the 8. We got a 2n here. Haven't touched the 3n, but here's the question of the day, Morgan. What is -6 minus 8?
2n?
Aha, that's often missed. In fact, we were talking about this right before the show. This is a very common problem that's missed. I'm going to go ahead and write this problem so you can see what we're doing here. -6 minus 8. It's a tough one here. Here's one way to think about it, though. I always like to do this little way of explaining positives and negatives. Let's say we have a game going on. We have the positive team and the negative team. This says that the negative team scored 6 points, and then the negative team scored another 8 points. So if that's the case, which team won, Morgan?
The negative
The
team.
negative team won. And how much did they win by?
By
The final score, right, was 14-0. So how much did they win by?
14.
14, that's it. So there you go. So this is one way you can think of that problem. Instead of a 2, because that's, like I said, a very common answer, we can put these both together. And because it's not multiplication, we have to go with the same sign there. Okay, so on the right-hand side, you got 3n minus 14. And on the left-hand side, you got 2n. Let's see if we can get that 3n over to the left, like you said, to get all the letters there. What do you want to do with 3n?
Divide by 3n?
We could, but we're not quite ready to do that yet. What if we want to just combine it? I like how you move the 8 to the right side by subtracting it. Can we do the same thing with the 3n by moving it over there to the left-hand side? In other words, we have a positive 3n here, right?
Yeah.
And you could move that to the other side by doing the opposite. What's the opposite of positive?
Negative.
Yeah, exactly. So we could do this and put a negative 3n here, and that would make that go away. But of course, we got to do the same thing on the other side. So we have to do negative 3n over here. It's getting to be a good one here. Okay, so now, Morgan, we have gotten rid of all the n's on the right-hand side, and all we have left is negative 14. So the next question for you is, what is 2n minus 3n?
Just negative n.
That's right, negative n. Well done. And if you had to put a number in there right before the n, what would it be?
1.
A 1, good job. And I like to show that because what you're really showing is that 2 minus 3 is negative 1. Okay, we got one last step because we don't really want to know what negative n is. We want to know what positive n is. So how do we get rid of that negative 1?
Divide by 1.
There you go. Divide by 1 with a negative sign in front, right? Okay, so we're almost done here. We're going to go ahead and cross those out. N equals, what is negative 14 divided by negative 1?
14.
Right, 14. Now, Morgan, how confident are you that this is the answer? Would you bet $5 on it?
Maybe.
Would you bet $10 on it?
No.
Okay, so if you're not that confident, we better go back and check to see if this really is the right answer. Let's go way back up to the top. You said it was 14. Can you help me by putting 14 in wherever you see an N?
Okay.
Okay. So at the very top, it said 2 parentheses N plus 4, right? So I'm going to put a 14 in there. And on the other side, it said 3 parentheses 14 minus 2, right? Okay, so what is 14 plus 4?
14 plus 4?
Yep.
18.
Good job. So we have 2 parentheses 18. That's on the left-hand side. Can you work this out real quick, Morgan? What is 2 times 18?
2 times 18.
2 times 8 is 16, right?
36.
36. Good job. So we're hoping that the right-hand side is also 36. Let's find out. What is 14 minus 2?
12.
Right. So we have 3 times 12. Is 3 times 12 36?
Yes.
It is. All right. So we have done the problem and we've done a check. And now you can bet your $10 that 14 really is the answer. Nice job.
Nicely done, Morgan. Thank you for that. And for going through that and making sure that 14 was the correct answer. We're going to send you home with an opportunity, a couple tickets to go see the Bakersfield Condors. So congratulations on that. Season has just begun. I know that one of the big games of the year for the Condors is coming up. They have the Kids Day, the Education Day, and then they have the Teddy Bear Toss right around Thanksgiving as well. So
Right.
2 big days coming up for the Condors. Hey, we have phone tutors available until 5:30, so if you need to give us a call, we do have phone tutors here, and you can give us a call just like Morgan did. But in the meantime, we're going to put Kaya back to work. So, over to the board, young lady. We'll erase that board. And we've got problem number 2 for you. Eileen and Michelle scored 48% of their team's points. If their team had a total of 50 points, how many points did they score?
What are we going to do with this one?
Okay, I'm going to make a proportion again.
Good idea.
So if we have 50 points and we want to know 48% of it.
Yeah, we could do it that way. Well, you said proportion, and I really like the fact that you wanted to do that. So let's set up this proportion.
Okay.
And we'll look at just the percent part first, okay?
Okay.
So if you were going to make 48% into a proportion or into a fraction, what would it look like?
In a proportion, it would look like 48/100.
Gotcha. So go ahead and write that on one side of that fraction, one side of that proportion. 48/100. Good. So the 48 is the part, right? And the 100 is the whole. Remember the problem said that the whole team scored 50, right? Okay. So where does that go? Is that the piece or is that the whole?
It's the denominator, so
Gotcha.
the whole.
You're exactly right. And what's the part that we're missing then?
We're missing how many points would accomplish 50.
Right. How many points did they score, right?
Yes.
How many points did those 2 players score? So that's the part we're missing up there. So what we have here is a ratio or proportion where you have the piece to the whole, the piece to the whole. As long as we keep that relationship, then we're going to be pretty good.
Okay.
I think you know where to go from here.
I
Go
do.
get them.
Okay, so 50 times 48. I'm going to take out the 0 because it's easier to do it this way and then add on the 0 later.
Okay.
So 8 times 5 is 40. And 5 times 4 is 20, plus 4 is 24.
Good.
So now our answer is 240, and then add that 0 that we crossed out over here.
Good.
So now we have 2,400, or 2,400.
Good.
Now all we have to do is divide 2,400 by 100. Now this is kind of an easy problem, because see these 2 zeros? You can cross those out and then cross these out. So now it's 24/1.
You can just cross out zeros? Why is that okay?
Because 100 has 2 zeros, and you're dividing by 100.
Dividing
and
by
every
100.
time-
That makes sense. So you're dividing the top and the bottom by 100.
Yes.
Okay.
And 100 would move the decimal point over twice.
Right.
So you can just look at it as every 0, you move the decimal point over 1 more.
Gotcha.
And then 24/1 would be 24,
Okay.
which makes this 24.
Good. So 24 what?
24 points.
24 points. Good. Now, we always like to check answers.
Yes, we do.
If you had to check this answer, right, and maybe you do, how would you check it? Where would you even start?
I would start by multiplying 100 by 24 to see if we get the same answer that we got over here.
Oh, okay. That makes sense. So you already know that 50 times 48 is 2,400. 24 times 100, is that the same answer?
Let's see.
Let's see.
Okay, so if we multiply 24 times 100, which I don't like dealing with zeros, so I think I'm going to cross these out again. And then we do 24 times 1,
Uh-huh.
which is 24.
Okay.
And then we add the 2 zeros again, so we get 2,400.
Back to 2,400. Gotcha. If you look back at our original proportion that you made here, this was a pretty neat proportion. You had x over 50 and 48 over 100, right? And this was 24, we found out the top one was, right? So another way you could check it, and I really like this one, is let's see if we would be able to multiply the same number on the left side to get the right side. So
what I thought.
50 times what is 100?
50 times 2 is 100.
Good. So we'd have to multiply times 2 on the top as well, right?
Correct.
Is it true that 24 times 2 is 48?
That's correct.
That's it. So that's another way to check it as well. Really well done.
Thank you.
Another nice problem right there. Well done as well. 636-4357 is that phone number. We'll be back with more right after this. Today we're at Browning Road Elementary School, and today we're here to Today we're at Browning Road Elementary School, and I've got Nancy with me. How are you?
Good.
All right. Now, I was just asking you if you know what prime and composite numbers are, and what did you say?
No.
You have no idea, right? Okay. Do you know what an even and an odd number is? Okay. Give me an example of an even number.
5? No, that's an odd.
That's an odd, right? So, okay, so here's what we'll do. We'll go odd, 5. What about an even number?
2?
2. Can you give me another even number?
4?
Another one?
A 6?
Okay. What about another odd number?
Another odd number would be 1?
Okay. Can you give me another one? How old are you?
9.
You're 9. Do you think that's even or odd?
Even or an odd? Odd.
Well, which one is it? You said both. Your second thing was right, though. Odd, right? Okay. So look, you can count by odd numbers, right? 1, 3, 5, 7.
9.
What's next?
11.
There you go, right? So what about even numbers?
2, 4, 6, 8, 10, 12, 14, 16.
You got it, right? Okay. So there's the difference between even and odd. Okay. Now, prime and composite talks about the factors that are in it. Okay. A prime number will only have 1 and the number itself. Okay. That's a simplified version. 1 and the number itself makes it a prime number. If it's composite, it has 1, the number itself, and other factors in it. Okay. So let's take a look at this first number you had, 5. What numbers can evenly go into 5? Can 1 go into 5? Yes. Okay. Can any other number go into 5? What number?
2?
Can it go in evenly? Like 2 times 2 is 4, 2 times 3 is
6.
6. So 5 isn't going to be composite, is it? Okay.
No.
Only 1 and 5 go into that. Okay. So what we'll do is we'll say that 5 is a prime number, because what numbers go into 5?
1.
And 5. And that's it, right? Only 1 and 5 go into it. Okay. So let's take a look at your last number here, 6. What numbers go into 6?
1.
1,
6.
6, if it's an even number, you know what else can go into it.
2.
2, right? 2 can go into it. How many times does 2 go into 6?
3.
3 times, right? So we have more than 1 in the number, don't we? There's other factors. So 6 is what type of number?
A composite?
A composite.
Composite.
Composite number, okay? So now, what I'd like you to do is think of a 2-digit number.
Okay.
And go ahead and write it on the board as soon as you've got it. Any number you like, as long as it has 2 digits in it. 20. All right. By looking at that, do you think that's prime or composite?
Composite.
You're pretty confident in that, huh? All right. So it's composite? All right. Why is it composite? How can you prove that to me?
Because you could multiply it and by most different numbers.
Put down some of the numbers that you can multiply it by.
4. And
So 4 times what? How does 4 go in there?
4 times 5.
Okay, so put a comma and put a 5, right? Because we have 4 and 5.
And then 10, and then 2,
Good.
and then
We always have 1, right? 1 and what?
20.
Okay, so write those down. We don't want to forget those. So it has the 1 and the number itself, and it has other numbers, right? It has other factors that go into it. So where does 20 go? Prime or composite?
Composite.
All right, put it up there. All right, I'll let you select one more number. All right, what one would you like now? All right, what do you think?
1, 3.
Okay, so far it satisfies both, right? Because it has the number and itself, the 1, okay?
And then 10 and 3.
Okay, and there are other numbers that go into that also, but do we need to know any more? We can tell right now what it is, right? What is it?
A composite.
Composite number, so go ahead and put 30 up there for composite. So I'm going to select the last one, okay? What do we already know goes into it?
1, and then 13.
Okay, so go ahead and write those up there. Can anything else go in there, do you think?
Yeah. We can.
Count by 2s for me.
2, 4, 6, 8, 10, 12, and 14.
13's not going to be an even number, is it? So we know 2's not going to go in there. What about 3? Count by 3s.
3, 6, 8,
Well, 3, 6,
9,
9, 12,
12,
15.
15.
Not going to go by 3s. What about 4s?
4, 8,
12,
12,
16. 5s,
5, 10, 15.
6,
6, 12, and
18.
18.
That's not going to work, is it?
No.
Should we keep going, or what are we going to know here? Because once we got the 6, we're not going to be able to do anything after that one, because otherwise it would have to be something with that. Okay, so what do you think 13's going to be?
Prime.
Write it up there. All right, Nancy, so now you've got a little bit better understanding on a prime and composite? Nice work. And a big thanks to all of the staff and students at Browning Road Elementary. We had a wonderful time while we were visiting out there. Speaking of elementary schools, Do the Math had an opportunity again to go out to Casa Loma Elementary. Let's check out with Devin again at the Casa Loma.
Thanks a lot, Mike. Back here at Casa Loma Elementary with the Mobile Oilfield Learning Unit with Traco Matthews from ERA, one of their ambassadors. We are underway with a lot of these stations. We figured we'd take the opportunity to start to look in and take a peek at what the kids are interacting with. So Traco's going to help kind of walk us through some of the stations here, starting off with Station 1 here.
Sure. So what you have here at Station 1 is a great overview of the industry. This station talks about the history of drilling, how the Chinese discovered it years and years ago. And it talks about being an engineer, being a geologist. And so they answer questions related to the industry and the history and opportunities. If they want to grow up and be an engineer or work in the oil industry, here are opportunities for you.
Looks like a part of that is being able to write and follow instructions. As we have
Absolutely.
Here with these gentlemen with the Legos.
Yes, indeed. So for every station, what you can see here is each of the pods robots has 4 different stations. And they spend 2 to 3 minutes at each station, and each one has specific instructions, and they write in their journal or they'll answer specific questions. And so it's a great step-by-step guide to the particular subject that they're looking at here.
I'll let these gentlemen get back into it because they're getting really hands-on with that activity.
Sounds good.
We'll check out station number 2 here, which seems to go a little bit more into the geology.
So this is actually, this is a little more technical. It actually is all about microorganisms.
Okay.
And so they start off here where they're actually looking at, taking a closer look at microorganisms, looking at fossils. So they'll look at different ones. And as you make your way over to this side, you talk about sedimentation and how the larger rocks drop first and then the smaller rocks and so forth. And then it wraps up on this other side with additional information about porosity. So you're looking at the process of permeability and flow and how the porosity with the different marble sizes impacts it.
So right here with the sediment piece.
Yes.
That was a really interesting case here as we flipped it over. Most of the liquid dropped down, but some of the sediments stuck up here. You think that would generally be the case, or would we have to jostle out a little bit to really notice what's inside? So give that a shot. Let's see what ends up happening. All right, and now bring it back. Let's see. Oh, there we go.
There you go.
Okay. So what does that tell you about what sediment can do when packed in?
The water can go in time instead of sinking on it.
So, I mean, like you said, it gets you really hands-on with the opportunity to interact with and experience what that looks like in a small scale level.
Absolutely. That's great.
Really interesting. So let's go ahead and take a look at our third station over here where I think I may have seen a robot arm.
I think you did. So this is incredibly cool. This is all about geosciences, geology, geophysics. So they start here with seismology, a seismology game, which is pretty cool. You see they're using these springs to try to shake things around a little bit. And of course they're gathering the data and putting it in their journals. Right here you see fluorescence. And so you're looking at oil fluorescence, and so they'll take a look inside of here with a light on. You'll be able to see some fluorescent rocks in there.
Okay.
And then you go to the fun station. So this is where everyone wants to hang out.
Not to assume that all these others are.
I want to go play pinball right now. True. But I think this is the one where folks, you have a difficult time getting them to leave, and it's because of this robotic arm. So what you're doing here is basically trying to simulate where, how folks can use a remote technology to produce oil. And so you have this robotic arm and it's picking up these cool little green rocks. You want to pick it up?
So let's see. Well, we have the different parts of the robot's arm labeled here. So we have the wrist, which looks like it turns it, right? We have the base, which looks like it turns it left to right, and then that elbow might be able to pick it up. And
right.
One of the things you notice with these controls, which I think is appropriate for engineering, is the fact that it's not instantly speedy. You're not going to put a light little touch on it and bring it all the way up. It's very precise, and there is a patience required to be able to have that much level of detail.
That's right.
So we got the turn on there.
Let's turn it.
So we're going to keep working on this one. So, I mean, the connections here with a lot of these stations are just kind of the foundations, not just of the engineering field, but of the main components of oil field learning.
Correct. So all of these technologies, we use some version of them in the production of oil. Definitely all of the geology and the remote. Oh, he's working it there.
We're getting there.
But we use all of these technologies, and so this is just a great, accessible, simple model for them to understand the basic technology in terms of how we produce it.
So Traco and I are going to come back a little bit later on in the show to take a look at the other 3 stations here and wrap things up from Casa Loma. But for now, we're going to send it right back to you in the studio. Mike, take it away.
All right, thanks for that. Nice to see Traco from Era Energy out there as well. Hey, we do have phone tutors available until 5:30 right now. We're going to go to the phones again. And Miracle, how are you this afternoon?
You said what?
How
are you doing,
You're on the
Miracle?
phone, right?
You said what?
As soon as you're ready, Miracle, let's hear the problem that you're working on.
I can't hear you.
Okay, so here's what I need you to do. If you're listening on the TV or the computer, turn that volume down. Just listen to the volume on the phone.
Okay, I did.
There you go. So as soon as you're ready, let's hear the problem that you're working on.
Miracle, what's your problem? We want to hear it.
Oh, okay. It's bracket 54,
Bracket.
divided by 9, or 9 to the second power,
9 to the second power.
subtract 4, bracket, times 11.
Wow, there's a whole bunch of numbers in this one. Okay, Miracle, what do you want to do first? Miracle, where do you want to start on this problem? Any ideas?
I'd say the 9 to the second power.
Good idea, yeah. Order of operations says we got to do the 9 to the second power. So what is 9 to the second power?
Is it
9 times 9,
is it
right?
9 times 2?
9 times 9, actually. Yeah, to the second power means 9 times itself twice. So what's 9 times 9?
81.
81, good job. Okay, and everything else is going to stay the same for now. Okay, what's next? Within the brackets, do you want to do the division part or do you want to do the subtraction part next?
The division part.
Right, and that looks like it's not going to work out so well. So what we're going to do is put this into a fraction, okay? So we're going to make this 54 over 81, which still means divide, and we'll keep it as a minus 4. Think we can reduce that fraction?
Can I do what?
Think we can reduce that fraction, the 54 over 81? Can we reduce that one? Some pretty big numbers, but I'm pretty sure we can reduce it.
Yeah.
If I look at those numbers, I'm thinking that maybe 9 can make those numbers smaller. So can you do a couple of problems for me? What is 54 divided by 9?
6.
Good job. So we're dividing both of these by 9. What about 81 divided by 9?
9.
Good job. That's it. So we just reduced this fraction, and we made 6 over 9. But we're not quite done with the reducing yet. We can still reduce it even further. So let's look at this 6 over 9. What if we divide both of those by 3? What's 6 divided by 3?
6 and 9.
Right, 6 over 9, that's right. But we want to divide them just a little bit more. So what's 6 divided by 3?
6 divided by 3 is 6 divided by 3, 2.
2, good job. And what about 9 divided by 3?
3.
That's it, you got it. So we're finally down to 2/3. We have reduced the fraction completely. And now we have to subtract 4. Miracle, how do you want to do that problem? We got to do 2/3 minus 4.
Do what? 9 minus 4?
2 over 3. 2 over 3 minus 4 is the next part of this problem.
Dang.
Yeah, that's a fun one right there, huh?
I didn't even get this, so.
That's a tough one. I agree. Well, let's see if we can walk ourselves through this one. We have a positive 2/3 and we got a negative 4. So they are different signs. And what's going to happen is
positive where?
we have a positive 2/3 and we have a negative 4.
I don't have a positive 2/3.
Yeah, that's how we got to the fraction, and we reduced it all the way to 2/3. And it's a positive number because it didn't have a sign in the front. So because these two numbers have different signs, we're actually going to subtract them. Okay? So over here to the side.
I'm like way up there by when we did 9 times 9.
Right. And we had that part, definitely. We had that part. The 9 times 9 was 81, right? And we did 54 over 81 because that's the best way to do that division part. So we have to do this problem now. We got to do 4 minus 2/3. And that's a pretty interesting problem. So if you can watch on your TV here, this is kind of a neat deal. I'm going to kind of cruise through this real quick. We are going to borrow because there's no thirds here.
Right now.
There's no thirds. We have to be able to borrow and see if we can get some more thirds there.
I'm in front of my TV.
Yeah, this is kind of a wild problem. I totally agree with you. So over here we have 3 1/3 is what's in the brackets. And that's a tough thing to do. But I think part of this problem that you can help me with next is we're going to need to change 3 1/3. So do me a favor, Miracle. Can you write down 3 1/3 on your paper? 3 1/3. Do you have that written down?
Yes.
Okay. And I need you to help me change that to an improper fraction. Do you know how to do that?
No.
Okay. Well, we have a method we can use. It's still going to be negative. The bottom of the 1/3 is a 3. And the big number is a 3. So what's 3 times 3?
9.
Right? And then we have to add in that 1 at the top. So what's 9 plus 1?
10.
10. So our new fraction that we have here is negative 10 over 3. And my 3 looks pretty poor, but hopefully we all know that's a 3. Now we have to multiply times 11. So we're almost done. And we're going to put this 11 over top of 1. So Miracle, tell me, what is 11 times 10?
110.
Good job. 110. And 3 times 1?
3.
3, that's it. So we ended up with a pretty crazy fraction. And I'm going to let you, on your own, be able to change this back to a mixed number, because that'll be a fun part for you to do after we're all done. But our final answer on this one, negative 110 over 3.
There you go. Nicely done, Miracle. A great problem right there. Hey, we do have phone tutors available until 5:30, but we've got a fast problem for Kaya right now. So, as a matter of fact, the problem has to do with speed, and you're going to do this in a speedy fashion, all right?
Okay.
Here we go. The fastest a human has ever run is 27 miles per hour. How many miles per minute did the human run? So we're looking for miles per minute, and I will give you 2 minutes to solve the problem.
Now I changed the 1 hour to 60 minutes so that it would be easier to make. So now.
So what you did here is you took care of all this stuff, right? Nice job.
Yes.
So we just have miles per hour. Good job.
And then in 1 minute, so now we do 1 times 60. So 1 times 60 would be 60, correct? So now we have to divide 27 by 60.
Okay. Can we set this one up like you did earlier? Because I love how you set this one up. We had 27 miles in 60 minutes. We want to know just exactly like that. I really like what you did there. Okay, see what you can do here.
So now another way to do it is 1 times 27 is 27. And 60 times x equals 60x. So now we have 27 equals 60x. So we're still going to have to divide 27 by 60.
All right, there's the part that we really need to do. 27, divided by 60.
Divided by 60. So I'm going to cross out this 0 and put a dot right here. Now I'll add the 0 back at the end. So I'm going to rewrite it over here. 6 divided by 27.
Now if you move this decimal here backwards, you're going to have to move that decimal backwards in the 27 as well, right?
Yes.
Okay, so go ahead and put the decimal between the 2 and the 7.
The 2 and the 7?
Yeah.
Okay. So now we have 6 into 2.7. So 6 goes into 27 4 times, which is 24. And 27 minus 4 equals 3. Then add a 0 and bring down the 0.
Good job.
And then 6 goes into 30 5 times.
Wow.
So our conclusion is 45.45.
0.45 what?
0.45 miles per hour.
Miles per hour?
Minute.
Miles per minute. There you go.
Nicely done. So 0.45 comes up with that one. Fast problem, done fast. 636-4357 is the phone number. We'll head out one more time to Casa Loma Elementary School.
Hey, thanks a lot, Mike. Back here at Casa Loma Elementary with Trico Matthews, our ERA ambassador with the Mobile Oilfield Learning Unit. We got some more stations to check out. We are here at number 4. Last we left off, we were at 3, so we're continuing that chain. So this seems to be focused on the exploration component.
Yes, so this is the process of how you explore for oil. So this is great. They have a little simulation here where they will try to find a little black dot, which represents oil. It's pretty cool. I don't know that there's a lot of science to this one, but they poke around and it basically gives them some idea of how difficult it is to find oil when you're looking for it.
We have the opportunity to explore some different samples as well, because different samples of rock are going to tell you a little bit about what you are able to pull from the ground.
Absolutely. So they have different types of stones: sandstone, limestone, and then they fill out their journal and they answer questions about which ones potentially have oil in them.
An opportunity. It looks like we have some drill bits in the case of certain materials that they're going to be drilling through with the right tool for the right job.
Yeah, so this is really interesting because most people think that getting oil out of the ground is pretty straightforward, pretty simple. You drill a hole, oil bubbles to the surface. That's not the case. This shows how technical and how difficult it is to get oil out of the ground. So some of these drill bits actually have diamonds on the edges, and because of the friction that you encounter when you're drilling, 2,000 or 5,000 feet under the surface of the earth to get oil out of rock, you've got to have some real durable, tough drilling material. And so this is a great example of how they approach that.
Heading over to the next station, it looks like we have an opportunity for the application part and how it ends up being utilized in society.
Absolutely. So once it's out of the ground, basically this is a great kind of puzzle where it talks about how it gets from the ground and basically how it gets to your vehicle. So they fill these little blocks in, and so they say, okay, what's next? And this coach here, she helps them to go through the appropriate process so people can go take the 9 steps from drilling rig, production, all the way to refinery, and then to gas station, your vehicle.
It looks like that factors into the business component as well, with some problem solving with the activity over here.
Absolutely, this is pretty cool. So this is the part that everyone kind of understands. They know you put gas in your car. So this is, how much does it cost relative to other commodities or relative to other products? So they have this here, 2 fluid ounce container of cologne, $60. And so you might think that gas is expensive, but this compared to, say, cologne, not so much. And so it gives them some context and shows how relatively expensive petroleum is.
So there's an opportunity to convert with gallons into fluid ounces and then work out some rate issues.
So they're doing some math there, and it's exciting, and I've seen them interact with this, and they tend to love it.
Over at Station 6, it looks like we get to explore some of the scientific and environmental impacts of the work as well.
So here's how they wrap it up, and they talk about the carbon cycle, and they talk about some geothermal. Over on this other side, this is a bit more technical. They talk about some of the different flow and viscosity, which is a great lesson for them to learn. And so they get to turn this wheel here. Yeah, so you can see there how they look at how the thickness and the viscosity of the fluid impacts how the little marbles and the little rocks move through the pipes.
So what do you notice about when the marbles are moving through the pipes more slowly?
This is a bit like water because it moves fast, it moves quickly.
Oh, that's interesting. So it's interesting how the white marble is going to move through a little bit more slowly than the metal marble when there's a little less force behind it. When you flip it over, it seems to be the opposite, where the metal marble seems to be forced through a little bit more forcefully in. See that there? We can see that, right? They were separated before, and now they seem to be a little bit together. What do you think that tells you about the relationship between the metal marble and the plastic marble?
Down here?
Dynamics isn't involved in as much as force and the ability for that plastic to be a little bit lighter in that liquid, but you can definitely tell, well, which of these do you think is a thicker liquid? Okay. So Draco, that visual absolutely helps out tremendously with being able to make that connection. Great example of that.
Thank you.
So I wanted to go ahead and wrap things up here at Casa Loma with the principal, Lamel Kwan and Traeger Matthews. Thank you so much for joining us. A lot of great work as always here today. And with your contributions to the show and the work you do with our kids, we wanted to present you with our complimentary Do the Math ceremonial tile.
You're so kind. Thank you.
That'll do it here from Casa Loma Elementary. Mike, back to you in the studio.
All right, thanks for everything today over there at Casa Loma Elementary with Devin. And right now, Kaya, wonderful work today, but you've got one more duty. You need to figure out who's going to see a CSUB athletic event. And it is...
Miracle from Sing Lum.
There you go. So congratulations to Miracle. Going to CSUB, do any athletic event of her choice. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama-Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.